So this is 4.6. This is number 21, and we're doing the inverse sine function. And the question is, does the mean value theorem apply to this function? Well, first of all, what does inverse sine look like? To do that, what does a sine function look like? And it keeps going, dot, 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 right? That's a sine function. The inverse is reflected about the x-axis, or it's rotated 90 degrees and reflected over the x-axis. You learned that last year. So what's it going to look like? And we're only going from 0 to 1/2. So we're going from 0 to 1/2. In actuality, that's 0 and that's 1/2. It's only that portion of the graph. Well, what's the inverse going to look like? It's going to look like this. I will draw it for you. And it keeps going in both directions. But this portion here is that portion here. So I'll draw it here. It's that portion of the sine wave. That's the inverse sine function. So the question first, does the mean value theorem apply? My first question, is this continuous from there to there? I say yes. There are no jumps, there's no holes, there's no gaps. Next question, is it differentiable from here to here? I'm going to say yes, because there are no sharp points and there are no discontinuities. So it meets the mean value theorem. Part A, yes, it does. Part B, what's the conclusion of the mean value theorem? The mean value theorem, the conclusion is there must be a point C. C must be between the endpoint, 0 to 1/2. There must be a C where the derivative equals the average rate of change. F of 1/2 minus f of 0 over 1/2 minus 0. So this is the average rate of change. That's the instantaneous rate of change. There's got to be a place where the derivative equals that. Well, what is this? That's the slope of the secant line. I should do that in a different color. What is this? It's the slope of that line between those 2 points. I don't know if you saw that. The slope between these 2 points is that. There's got to be a place where the derivative equals that. I'll do the derivative in green. So it has to have that slope. There's got to be a place where that's true. It looks like right there. It's hard to see. So it looks like there's a point, like right there, where the slope of this is equal to the slope of that. That's kind of pictorially what's happening. So let's find each of these. Well, first, what's the derivative of f? You should know the derivative of that is 1 over, you should know this, square root of 1 minus x squared, but in this case it's c squared. You need to know the derivative of arc sine, arc cosine, arc tan. That's part of your knowledge. So what's f at 1/2? If we put a half here, it's asking what angle has a sine of 1/2? A sine of 1/2 occurs at pi over 6. That's pi over 6. Then f of 0, whoopsies, I didn't mean to do that. F of 0, you put a 0 here. It's asking what angle has a sine of 0? And that answer is 0. Which is pi over 6 times 2, which would be pi over 3, because we multiplied by the reciprocal of that. So we end up with this equation. According to the mean value theorem, you're guaranteed that this will be true. I'm going to reciprocal both sides. I'm going to square both sides. I'm going to subtract 1 from both sides. I'm going to multiply both sides by -1. Whoops, I don't know how that happened in my brain. It's not even close to being the same. And then I'm going to square root both sides. Okay, first note, the C that's guaranteed is between 0 and 1/2. I claim it can't be negative because that's not between 0 and 1/2. So the C that they guarantee is that. As long as that number is between 0 and 1/2, and I believe it is. I hope. I don't know if it is or not. Well, it's got to be because it has, the mean value theorem guarantees that. So that's my answer, and I'm sticking to it. That was part B.